Dear friends, Maths Aspirants Groups organizes online problem solving sessions to help the students who prepare for different national level competitive examinations like CSIR NET, GATE, JAM, NBHM, etc. As a part of that lecture series, today we have a session on group theory by Mr. R. Jayakumar. He is a research scholar, senior research scholar at IMSC Chennai. Mr. Jayakumar did his MSc from Ramanujan Institute of Advanced Studies, University of Madras, and he cleared CSIR NET examination with All India rank 53 in 2015 and with All India ranks 27 in 2017. Also, Jayakumar qualified NBHM examination in 2016 and now pursuing PhD at IMSc Chennai. I would like to thank and express my gratitude to Jayakumar for joining with us. I hope that today's session on group theory will be really useful and helpful to all those who are seriously preparing for competitive examinations. I welcome everyone to this program. Welcome, Jay.
Yeah, it is very honored to be here actually. I'm really here to share something rather than teach, okay? I'm also a student and I'm going in the path and I like to share something. That's why my title itself is something like that. So, yeah, so the title itself, I'm just choosing that the fences, the word fences. We have a normal subgroup concept and that itself makes a very nice region of a group theoretical. In the group theory, it occupies something and we are just viewing from the fences. I'm just inviting you all to see from my point of view this concept, okay? So it's a mostly a problem-oriented introduction. As I informed that most of you are preparing for these exams, so I rather go to the theory which is oriented, I mean problem-oriented theory, okay? And this is not all, but still it will give you a certain view. We are just viewing from the fences. So I would like to get a more idea from viewing outside of this concept. We are not going in, but we are going around and see what it is. Okay. So basically, I prepared this thing within 4 5 hours. So there may be a typo. All these corrections are no, it's welcome. If you give me a suggestion and a correction, grammatical as well as English typos, I will be happy. I will correct it and I will give it to sir later. And I need to add something more. Okay. So let us develop theory from the base. From the base means like from the root. This is what they teach us in Institute of Mathematical Science. If you wanted to really go for it, try to start from the root and you can go along with it. Okay. So let me go from start. So necessity invention of, so, I mean, necessity is already a mother of all the inventions, right? So we have to find what is the necessity thing, right? So simple introduction we need, like, what is the need for study a normal subgroup, okay? Normal subgroup is like something which breaks the group, which I need to break the group. Like I like to understand the simpler structure, smaller structure than rather than the bigger structure. That's just the need to read about the normal subgroup. Like we like to break, okay? We like to break all these things. I will I will tell you what is the real meaning. I'm using a rough word, but I like to tell you in the later what is that. And also I will give you the link where you can find the ideas. Okay. Okay, fine. So why we need to break the bigger group? Because big thing is always complex to understand, but if I can able to break it into smaller pieces, brick by brick, I can able to understand, right? So brick by brick, I can build the group. So groups are basically built through normal subgroups. Okay. In fact, in the normal subgroup, there is something called simple. And simple subgroups are the exact block, like a home, no? Brick, exact block. So that's how the bigger groups build into. If you are able to understand all this normal, I mean simple groups, then things are much more fine. In fact, in the finite group, as far as finite group concerned, these things are done very much. So let's go. So I'm just making a point. As far as simple group, when it's finite, it's we can go deep realm. Deep realm means very deeply. And if it is finite, it is much more. After many mathematicians, not one, two, many mathematicians, I had a really nearly 2,400 plus papers together gave us simple finite groups. Okay, I will tell you what are the simple finite groups and why that is so important in our discussion furtherly. But this is a sort of a motivation. Motivation means like we have to move, no? We have to move. We are in the positions to do something, but we wanted to understand why we need to do. Okay. I'm telling you, all these finite groups are made using only four types of groups. And if you're able to understand four types of group, then that's it. And I will tell you how the step-by-step process is going on. Okay. Okay. Yes. So let me start with a very basic definition. The basic definition is suppose we say n is normal, basically means what g n g inverse equal to n. I'm putting here just to reduce my work. Okay. But one can prove actually this is the equality. For every G belongs to capital G. This is what normal subgroup. So the entire theme of this talk, it's about normal subgroup and it's very simple, nice consequences where you can find it in the NBHM and JAM exams. Simple only, not much harder. Okay. This is a notation I like to use. In higher math, people use this is a notation. Okay. If it is this, it's a proper, meaning it's proper. If this is the thing, it's a group, just a subgroup. If this is, it's a proper subgroup. People use this notation, and this notation is mainly used for to denote the normal subgroup, reduce our writing work. That's it, and it's much more compact, no, usable. So this is a notation I also like to use. Okay, just to mention that it is less work. Also, one can prove that another aspect of understanding this. Remember that for certain G, any fixed G from the group, I'm for this talk, I'm assuming that whoever attending knows the basic group thing, like a definition of group, definition of normal subgroup, certain things about Lagrange's theorem, okay? So for G, I'm defining a map from G to G like this. X equal to Gx G inverse. And remember that this is my definition of normal subgroup. It is exactly same as saying that Cg of n, which is G n G inverse equal to n for every G. And that is same as saying Pg of n is n. You may ask at this point, what is the point of seeing another definition or another perspective? In a end of this talk, I will explain why this perspective also helps, and I will linger a little bit about the next level of studies. Okay, just to make a note that it will come in the end. Okay, this idea, this perspective, this will again come in the end. Okay. Now again, so few known facts. I just wanted to recall so that we have a solid background to start. What is the few background? That few known fact. That first of all, the trivial group. If you start with a G, everything we have identity. The identity and the group G itself. Okay, identity and G itself is normal. So there are very easy and it always together. Okay, always together. If identity and the group G itself normal, and it is interesting to know whether there are other normal subgroup or not. If there is no other normal subgroup other than this, that group called simple actually. Precisely two normal subgroup, then that group is called simple. It's a very easy definition, but still it controls a very major part of the ideas, okay, in the group theory itself. Knowing that itself, how to say, very few people in the world know in both the direction. I will make remarks about this thing later and just motivated towards these ideas. Okay. So in abelian subgroup, every subgroup is normal. Okay. What is abelian subgroup? We know A dot B equal to B dot A. And we know that, right? If this is the case, G n G inverse equal to G inverse n, which is n. By the way, what are you meaning by G inverse? Is set of all G n G inverse such that n varying. N varying, that's it. And you can see that in the if it is abelian group, it will commute. It will commute so that this will cancel and I will get n. Now one can ask reverse question. Okay, this is one of the interview question asked in CMI for the MSc student. So in abelian group, we know that every subgroup is normal. Suppose I will give you the reverse idea. So two questions are asked in the thing. I will tell you later. First question is, if I will give you a group where every subgroup is normal, can you say it is abelian? That's a question. In fact, they added little more. They asked the same question. I will give you a group where every subgroup, proper subgroup is cyclic. Can you able to say the group, the original mother group is cyclic? These two questions they asked in MSc level interview for CMI, right? In CMI. So we will deal with that question, two questions. Okay. Also, I just wanted to mention, many of you already know about it. Okay. Am I audible, right?
Yes, sir.
Yes, sir. Okay.
Yes, yes.
Many of you already know about
Yes,
this
sir.
AN and SN, right? The nature of AN and SN one can understand from very deep perspective. Just I wanted to say, AN is a normal subgroup of SN just using the sign momentum. This will also come in the end. But I like to give you from another perspective, not in the same perspective, from matrix perspective. Okay, remember this also will come in the end from the matrix perspective. If I have a time, I will do it from the matrix perspective. That is much more helpful to understand. If you have a good background in linear algebra, which is easy to realize from this, I mean that point of view. But it's up to you whether you are abstract person or that person. You have to decide. But I will give you at the end. Okay. Now, so one more thing I like to say that index 2 subgroup is always normal. Many of you know these things because everyone preparing for JAM and NVHM, CSR exams are must come across, no, at some point of day they come across these things. Index 2 subgroups are normal. This is our basic setup and I fairly assume that many of you are known these things, okay? Fine. First thing, let me, as an example, let me introduce this Q. One can, in fact, give a talk on this, give a solid 2-hour talk on this particular thing. I have seen some notes, they mention some nearly 20 points about this group. I like to take 2 points which are relevant to us. First of all, Q with addition is abelian group. Oh, we all know this, right? So any subgroup of a abelian group is normal. Just I mentioned here, any subgroup of abelian group is normal. So abelian, so this is genuinely a factor subgroup. Okay? So the reason why we wanted a normal subgroup, we like to understand this quotient group, right? What is this? G dot n such that n belongs to G belongs to G. I like to understand this quotient group, and of course, this quotient group is seemingly smaller. Surprisingly, this is not the case of infinite. Okay, in the infinite group, even if you cut down by proper subgroup, very non-trivial subgroup, this is not happen. There's one specific example which is much more interesting and very geometrical. It is being asked in the NVHM 2016 exam. That will come up. Okay, I'm just keeping up you to have a hope so that you can attend this entire lecture with a perspective. Okay, I'm just curving our perspective towards all this normal subgroup. As I mentioned earlier, one can give a solid talk on this. Nearly 20 plus points are there. But I am interested on this. Only through idea of the quotient group, we can construct this. After constructing this group, it has a specific properties. First of all, let us see the specific property. One such property, I want the two property. One such property, every element of this is a finite order. After constructing this, we can say that every element of this has a finite order. How? For the practice purpose, let us do this. What is this? It is P by Q plus Z such that P comma P belongs to integer, Q belongs to natural number, and GCD of P and Q is actually 1. Of course, if you take any typical element and add them to itself Q times, you will get Q times P by Q plus Z, and which is nothing but this one. So it will get cancelled, and that is Z itself, no? The word, I wanted to use the word, that's why I introduced this. This P is an integer, so it will get observed. In general, when I have a subgroup and AN equal to N, that means this A belongs to N, and we use a very beautiful, catchy phrase that this A is observed into the group, subgroup. The A is just observed in the subgroup. So since here P is an integer, that is getting observed in this thing. Okay. So I'm using many synonyms. You can see in my talks. Generally, in my talk, I used to have many equivalent phrases and synonyms so that whenever you go for exam or interviews, it is easy to face it. Okay. The major difficulties where I faced, and also some of my juniors and seniors face, that they may not understand the language that professor asks in the interview, right? So that's only I make a lot of different catchy phrases and synonymical terms so that people can understand, so that they can go to the interview and face it. So we don't know who is going to be in the interview or who is going to set the question paper, right? So that's what I like to use the word. This is getting observed, okay? So it's going inside this. Okay? So let's see. So it's clear that every element has a finite order. But that's only one property. Another property, given any natural number, there exists an element in the group of that order. That is, I start with a natural number, let's say, fixed. And look at this element, 1 plus z. This order of 1 plus z is actually n. So this group also, it's a very important group, okay? So let me explain you what is a necessary thing I need to discuss this. This is one of my interview questions when I came for PhD in the Institute of Mathematical Sciences. They have a lot of questions, and this is one of the sub questions. Okay, they also asked me one question that do we have a group where all the proper subgroup is finite? Okay, do we have a group where all the proper subgroup is finite? That's a question to me. And through the question, working out of question, this came again. And you can see that any BSc level student who is had a little bit of background in group theory can understand this. So this is one such example. Okay. So later on, I got I got an appointment with a professor, and I asked, it's like, what is the point of asking this kind of questions? And he explained me, he very kind and explained me that whether I'm able to understand, that is the main thing. Another thing, the richness in the mathematics is measured through how many examples you know and how well you know. Not only how many examples you know, but how well you know about this thing. For example, for instance, take this example. I can make another point. This is not cyclic. But all finitely generator subgroup is cyclic. This is another fact. And remember that this all comes through a beautiful thing of the quotient. Okay. Okay. This is very practice purpose. I'm not looking for this. My main postings are in the back of this notes. I'm not really looking for this. Let's go on. Just a practice purpose, just make you too comfortable. Right. So these are the equivalent condition you must have seen, right? So let's go through one by one. Let G be the group and H be the subgroup of G. The following statements are equivalent. If A, B are same coset, that is A comma B, like in the same coset, same left coset, let's say for us left coset, of H, that is saying that AH and BH is equivalent, okay? And that is same as saying this. And this is the most important thing, okay? B inverse AH is belongs to H, equivalent to say that AH equal to BH. These are certain some equivalent condition, whether this is normal or not. Okay? And you can also observe one more thing. Okay? The one who is in the level of BSc can observe as an information perspective. In the level of MSc, one can observe in the confirmation perspective, but in the PhD, one can observe in the transformation perspective. Okay, you may ask me a question that what is the meaning of transformation perspective? I will tell you. So for the first one, anyone who's first encountering this can understand from the, okay, this is just information, just the feeding, information mind feeding, right? The PhD guy maybe already seen this thing. So it's for him, it's like a revisit, confirmation. But in the PhD level, I'm using another term of transformation. What is the transformation? If you see the notes carefully, for n, I'm using normal. Normal, I'm using n. And just for general group, subgroups, I'm denoting h. Okay? Note that also along with it. So whenever there is a generally I'm talking, I'm using n. But I wanted to particularly talk, I'm using n, not h, particularly about normal subgroup, just for the psychological perspective. Okay. Okay. That means whenever I wanted to come from something to normal, I use h. But if I say something is normal and starting the problem or theory, I will use n. Okay. Just observe that is also in the note. Okay. So again, there are equivalent conditions so that if I have a normal subgroup, if I start from the H, sorry, unfortunately that is, okay, sorry, unfortunately that is there. So what I wanted to say here, if H is a subgroup, the three things are equivalent. One, this one, H is normal subgroup in G. Okay, that is left, the left coset, G H equal to right coset. Left coset and the right coset, as a set, theoretically they are equivalent. One has to be clear in the point of view, set theoretically they are equal, not term wise, point wise. This is not true. I'm not saying this is true, but when you collect as a set, sorry, G n, so that n belongs to n. When you collect as a set, and this set is same, but not term by term. Okay, remember that. So let me put it H. That's the correct term. Not term by term. Okay, I'm not saying that. Term by term. Okay. Basically, what this says that if you have a AH and BH, and this AH and BH can be think of here, that is A, B, H and H, which is ABH. That's what I'm saying. Okay. Basically, the definition of coset multiplication is well defined. It's closure, so that one can talk about the factor groups. And again, I just wanted to make it as a point so that this all you are like a confirmed thing. Most of you are encountered this thing. Okay. So there are few known facts that okay, let me go to the next level. Intersection of a family of normal subgroup is normal. Center of always normal. And this is I want this. Center of a group is actually normal. In abstract level, you take any center. This is always normal. Why? Because center commutes with everything, right? If I start with a center element, let's say this is my H. And since center commutes with everything, I will get this and this for every year. This is term by term. This is term by term. In fact, any subgroup that is inside the center is normal. This fact is actually going to play a very big role in studying of P groups. I'm just making a point here. This fact is going to very much helpful. Okay. So let me pause a moment. I will tell you the idea. In the P group, there is a only and a very beautiful, very powerful theorem that the center of the P group is always non-trivial. Using class equation, one can prove. Then almost all the proofs go using only by induction. Most of the proof which I have seen in my life so far uses only the idea of the induction. And this particular theorem is very much useful that time. The particular observation is very much useful. In fact, this is not a big theorem, but it's a very rather, I can say that it is a observation which is so much useful. Okay. But our theme is not this. We are not here to study P group at this point. So let me continue. Okay. Okay. This is the question they asked in CMI. Okay. So it's a MSc entrance level interview type of question. In fact, this is asked in the NVHM and many places. The MA MSc scholarship in NVHM, they asked this question. So let us understand this. Can we say if all the subgroup is normal, then can we say the group is abelian? This is one question. Another one, can we say if every proper, remember that proper, I put proper subgroup of a group is cyclic, then group is also cyclic, the original group also cyclic. This I can answer. Look at S3. Just 6. That is 3 factorial. And this is 6. And the proper subgroup, okay, suppose H is a proper subgroup of S3. And the order of this is actually 1, can be 1, can be 2, can be 3, can be. Maybe. But we know in the 1, 2, 3, all are prime. Using Lagrange theorem, one can tackle that this is always going to be a proper subgroup and cyclic. All this proper subgroup of cyclic, but S3 not even abelian. Okay, this is like a simple level just to make sure that this statement is false. The statement is false. This is also false. I will give you the idea. So I made a one note using notability, which we are going to see. This is the notes. I will show you the notes. For both the purposes, like Q said, we have to understand this guy. This is the notes I made. I uploaded into many places. I will share the link also. This is the group which is going to work as a counter example of many obvious statements like this. Just look at the obvious tempting statement. When I come across this first thing, one of my friend named Arpit, he was a student of CMI at MSc. He and his friend came for the interview, and to his friend they asked this question. Out of temptation, his friend said, yes, this is true. And they also asked this question. Out of temptation, he said true. Yeah, the group must be abelian in both the cases. Okay. But that is not true. This both question, in fact, many other questions can be tackled using only this group. Okay. So let's have a digression. Let's understand this group as a case study so that this will help us in many points. First, Q8. What is Q8? It's called a quaternion group of order 8 and it is denoted by like this. Plus or minus 1, plus or minus I, plus or minus j, and plus or minus k. I am sure that you must have come across this thing, right? Okay. But with generators, this and relation, in terms of generator and relation, whenever there is a group, I love to have a generators because generators are smaller, easier, and the beauty is that everything can be catched with the generator. For example, this guys, the K. I'm not talking about K here as a generator, but K can be catched using IJ. Minus K can be catched through minus JI. So in terms of generator, it's easy because generator is smaller subset and I can able to, control many of the things. Basically, what is cyclic group? Cyclic group, it is actually generated by one single element. The power of the cyclic groups hides here that one element, it's enough to control everything. So all this thing we have to worry about that one particular element. That's how the cyclic groups becoming so easier. And also here, it's something like this. Okay, so the in terms of relation, so you can may ask this question. These relations are little easier because it's resembling the complex. Okay? Complex number. I'm just resembling the complex numbers. So I square and j square k square minus 1. I power 4 is 1. So as j power 4 k power 4 is sort of resembling the complex number. So not much thing is going on. But how to remember this? That's why in the Galilean book, they gave a very nice trick. The trick is you take I, you take j, you take k, and draw this diagram. And I have seen in Galilean book only. Okay, so this ij equal to k. That is, if I multiply these two things, I will get k. If I multiply these two things, I will get I. Okay. If I multiply these two things, I will get j. And this arrow specifies very nicely that the reverse is also there. If I multiply this one, I will get j, but in terms of minus. Okay. J in terms of minus. J and I will get k, but in terms of minus. So this 6 relation can be put through the single clockwise direction, 3-pointed clockwise direction picture, so that it is easy to understand. No need to mug up, right? It's very hard. So how to understand this relation? And remember, the key point is that this is resembling just complex numbers. This can be come through of this thing. Okay? And I really wanted to say thank Galleon to introduce this thing. I have seen Galleon book only. Okay, in the Galleon book. I don't know if there may be another thing it's already introduced, but from my perspective, I have seen first times in Galleon book only. Okay, so that's what I explained here. Okay, so let's have an excuse to understand. So for this talk, I supposed to send you with a title of a normal subgroup and a quotient group, but I I requested sir to just put a group theoretical so that we can have a very wide perspective of group theory. Although we have a very specific task to do in this talk, but just wide perspective. I use this example as an excuse to recall the theoretical part. Okay, as a case study, I wanted to climb the theoretical part. We all know about Lagrange's theorem, right? I wanted to make sure that we are understanding the subgroups of this thing. Okay, first, I just take a random subgroup and it can be of order 1, it can be of order 4 and 8 just by Lagrange's theorem. It should be a divisor. The order should be divisor of 8. So it can be 1, 2, 4 or 8. If it is 8, yeah, we know that is Q8 itself. If it is 1, it is 1 itself, the identity itself. And let me again mention you, it's of plus or minus 1, plus or minus 8, plus or minus j, plus or minus k. Okay. And you see that if it is order 4, order 1 is tackled, order 8 is tackled. If it is order 2, that's what I have written here clearly. Let me do it again. If it is order 2, suppose order 2, I should put the identity, then I have one more element I can fill. So how I have a 7 more left, namely minus 1, plus or minus I, plus or minus j, plus or minus k. And remember this diagram, this is most useful diagram. If I multiply I and j, I will get k. I cannot allow I, no? If I allow I square will give you minus 1. So that should be here because of the closure property. So I cannot allow I. For the same reason, I cannot allow minus I. For the same reason, I cannot allow this and this. The only thing I can allow is actually minus 1. I cannot allow I because I square makes it minus 1. Minus I also. Minus I square is actually minus 1. Minus minus plus, then I square will be given this. So for the same resembling reason, complex resembling reason, this is true. I cannot allow. So there is only one subgroup. And this is a beautiful place that if just making a result or fact, it can be tackled from two different point of view. I'm saying that here, this is center of Q8. It can be tackled from two point of view. One is P group point of view. I will tell you about that orally. Another one is our point of view, which I mentioned as a result. Fact that suppose H is a order 2 and unique subgroup. Not even order 2, just order K inside G. Unique subgroup. That order. Yes, H is normal. H is normal. But in fact, order 2 and normal implies H is inside setup G. This result I have included in the later notes, but let us understand first. In the order 2, we got a one subgroup which is plus or minus 1. By brutal forcefully, we are checking, okay? We are not using much terms, but we are checking brutal forcefully. And that is the only one element of order 2, and it gives us one thing. I'm saying that that is a center. First of all, one more beautiful theorem that we have to make it, G by Z of G is cyclic. Plus, if one only, in fact, if one only G is abelian. This three theorem, necessary three results telling that first I have a subgroup of order 2. And that is a unique subgroup of order. There is no other subgroup of order 2 that says that normal using this. And if it is 2, it is saying that it is, should be in the center. So far I got inside the center. But center can be 2. That is not a problem. If center is more than 2, it must be 4. It must be 4. If it is more than 2, it must be 4. But this theorem indicating me, warning me, telling me that if G by center of G, that is 8 by 4, is actually 2, then it's prime cyclic. And that says that the group must be abelian. But we know that, no, the very basic construction of the group, look at that, Ij equal to K, and Ji equal to minus K. So it's not abelian. The very definition says that this is not abelian. So the 4 is not possible. 4 is not possible. So this is the exact place. Exactly, this is the thing. It's possible. So we got a center. So this is our perspective. And also one can understand from the P group perspective, just I mentioned that P group always have a non-trivial center. Of course, 8 is 2 cube. So it's a P group. It's have a non-trivial center. It can have a 2. It can have a 4. It can have a 8. 8 is not possible because this is not abelian. It can have a 2. That is what I wanted to say. And you can say that it cannot be 4 using the same theorem. G by Z of G is cyclic if and only if G is a So let us go for order 4. So let me go for the order 4. So let me erase this. Of course, in the order 4, there are 3 places I need to fill it. So let us see that suppose a place consists of -1. Then I have only remaining plus or minus I, plus or minus j, plus or minus k. If I allow I here, suppose one of the place, then I will take care of all this thing because I square is -1, I cube is minus I, and I power 4 is 1. So this generated, if the I comes inside, of course, the inverse and everything comes. So it is generated by I. Generated by it. Suppose j come in the same way. J come in, j square will come, which is -1, j cube is minus j. So that will take care. It's generated by j. If k comes in the same way, k square, k cube, k power 4, which is k, which is -1, which is minus k, which is 1. This will take care. It's generated by k. So these positive choices, if one enter, then that will take care of everything. And remember that we are dealing with only with the order 4 subgroup. Now, if I start with minus I, if minus I include, the inverse of minus I is a plus I, because I minus I is nothing but minus of minus I square, which is minus 1, minus into minus 1, which is plus 1. So if I include minus I, automatically I comes, it's reduced to the previous thing. Suppose if I include minus j, if one of the element is minus j, then it happens that j automatically comes because they are pair. J and minus j is pair. I and minus I is a pair. That's the inverse to each other. So similarly, if I include minus k, so it says that if I is there, it's going to controlled by I. It's generated by I. If j is there, it's generated by j. If k is there, it's generated by k. So it seems that we are not getting anything more than this. That's why in the order 4, I had to put only these 3 things. This one, and this one. The subgroup is okay. And remember that here I made a point, index 2. Index 2, no, somewhere I made a point. Index 2 is always normal. Somewhere, index 2 is always. And this is the point I'm using. All these things are index 2. So index to normal. Okay, let me say first, trivial is always normal, whole group is always normal, center is always normal, index 2 is always normal. So that all the subgroups are normal, but the group is not even abelian. So we tackled a very nice question of CMI. The nice question of CMI that all subgroups are, this is normal. This group is abelian. Answer no. Logically necessary development using fact we develop. Answer is Q8. Similarly, note that this is cyclic, generated by one element. This is cyclic, generated by minus 1. Because minus 1 is there, minus 1 square is plus 1. So generated by, this is cyclic. Order 2 is cyclic. Order 4 is cyclic. All the proper subgroups are cyclic. Again, I'm just making that all the proper subgroup of these are cyclic, but the group is not abelian. So one can use the same example. I wanted to say one more fact about this because I like this group. You all remember Cayley's theorem, right? Many questions being asked from this perspective in CSIR. And a good student will go and search and find such things, okay? Okay, so let me say that. Cayley's theorem just saying that if you start with a group of order n, then this can be thought of subgroup of Xn. That means there is isomorphic copy of G inside Sn. But there are limitations. The question is, even if you start from a smaller number, let's say 5, group of order 5, Lagrange's theorem says it's cyclic. But I need to understand 5 factorial. That is huge, 120. Even a small number like 5, even small number level 7, have to understand something more than 1000. That's the problem in Cayley's theorem. So people started asking a question. To understand even a smaller single digit group, why should I go to 1000? Can we do something? Can we do something in the sense, can we reduce the number n? In fact, that is not possible. Here I have mentioned very clearly that the deeper result using group action, all this video can be found in my YouTube channel, okay? Deeper result. Q8 can be thought of subgroup of Si by Cayley's theorem, but not anything less than that. Not anything less than that. This is not true. Not anything less than that. So we have a limitation for Cayley's theorem that Q8 cannot thought of subgroup of any Si, or maybe S1, S2, S3, S4, S5, S6, S7. Up to S7, there is no subgroup. In particular S7, okay? S7. There is no subgroup which is resemblance to Q8. Okay. So only the first time I'm getting Q8 is 8. And remember that is so huge, 8 factorial. In fact, within this few minutes of framework, we completely unable to understand the structure of the group Q8. But Kaila's idea is to understand all the final group. It is enough to understand the essence. Of course, that is true. He proved that. He technically proved that that is true. But see the limitation. And this is why it is necessary to even develop the other tools. Maybe Kele thought that it is okay at the point. If you're able to understand the essence, then it's okay. You can able to understand all the finite groups because every finite group has an isomorphic copy in essence. That's okay. But the limitation says that within few minutes of framework, we can able to understand and make a lot of counterexample using Q8. The problem with here, I should go to 8 factorial. So this can be able to give a counterexample of that perspective. Okay. One more thing which I have mentioned here, I will share these notes. Q8 is basically order 8. Similarly, there is a dihedral group. You must have come across or known this name, dihedral group. If you start with a square, you will get a order 8 dihedral group. Or those are isomorphic, and you can see that no, it is not isomorphic. It is not isomorphic. Okay. There are many order 2 elements are there in the dihedral group, namely reflections. But in Q8, we have only one element of order 2, so they are not isomorphic. Though they are not isomorphic, they share the same class equation. So this is also not true. If you have an equal class equation, can we say the group is isomorphic? No. Any group of order 8 has same class equation as long as non-abelian. Both dihedral and this are not abelian, but they share same class equation. This has being asked in the exams. This being asked in the exam, one of the CSR exams. If they have a same class equation, then can you say it is isomorphic? No. D that coming from the square is a 2 into 4 order 8 group, dihedral group of order 8, and Q8 is not isomorphic because they have more order 2 element. Here we have only one order 2 element. They are not isomorphic, but they do share. In fact, abstractly you can prove any group of order 18 and non-abelian have only one class equation. This one. Okay, I will share this notes. No problem. Okay, so let us continue our thing. Yeah. So I mentioned here. So just I mentioned here. Yeah. But so if somebody reading this notes, just to mention that I had taken these things. Okay. I want to talk about simple group, but I will do it later. And I said that is a building block. Let's pause the moment. Yeah, this is the thing I wanted to talk more. And now many questions can be asked from this. If you are able to understand this particular theorem, you can able to do and make your own question. And certainly I have a belief that people who understand the question setters who understand this theorem making a lot of questions in JAM exam CSIR. Okay, let us understand this. I start from a group G and I have a G dash and a homomorphism. Let's say P. P is a homomorphism from, just to make confirm, I'm audible clearly, right?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Yeah, thank you. So let's understand this is slow because many questions which I taken from the question papers based on this. G and G dash between the two groups. So let me call domain. And I will give a name codomain usually. And between this, I have a homomorphism. At this point, I'm not assuming anything like 1 onto, no assumptions are there. Everyone who just reading or studying the group theory might have come across this thing, kernel of P. Suppose this is a onto map and this is isomorphic. So the G by kernel of P is isomorphic to the image T. Okay. But I'm making something differently. I'm saying that forget about this. Just I'm saying that if I start with a G and a G, take any normal subgroup. Inverse image of that normal subgroup is set of all A belongs to G, or let's say G belongs to G such that G, P of G belongs to N. This is normal. So the inverse image of a normal subgroup is normal under homomorphism, like a continuous function, no? Inverse image of open set is open. Suppose we read a little bit of topology. The beautiful definition we have that inverse image of open set is open. In real analysis also they use this thing. I'm using that term because that is much more easy for us to even catch. Inverse image of normal subgroup is normal. I rather don't want to prove this, but I will tell you the power of this problem. But before that, I just leave you with a question. What about forward direction? What about forward direction means I start with a G dash, take a normal subgroup H, let's say normal. What about phi H? Is it normal in G dash? The answer is no, but it is if it is onto. But it is if it is onto. I strongly recommend you to try. Even if you don't get it, you can go and see notes or internet to prove this. I strongly recommend about the forward direction. If it is onto, it is true. If it is not onto, in fact, this question has a lot of problem, even how to relate. But inverse image doesn't matter. Inverse image of this thing is always okay. With the help of a linear algebra, little linear algebra, okay, let's understand that. With the help of a little linear algebra, we can understand that the map determinant of the AB matrices GLN of F, right? What is GLN of F? GLN of F is set of all matrices, n cross n matrices over the field. Any field, doesn't matter, any field. Bit of A is not equal to 0. Basically, collection of invertible matrices. Or yes, all collection of all n cross n invertible. It is both equivalent condition, no? So we have a very good, strong help from the linear algebra, and it says that. And it also says that from GLN, if you go, it's going into F star. That is determinant map. It's non-zero. F star means F removed 0. Just remove the 0. F removed 0. This map is a homomorphism. Linear algebra took the hit. I don't wanted to prove this because linear algebra all this thing. Det of A and det of B. So it is basically group homomorphism between GLN of F to F star. But remember that. Now this is the beautiful thing. Look at F star. Look at F star. Basically, F star is a abelian group. After removing 0 from the field, if you see the field axiom slowly, after removing 0, this is an abelian group. So every subgroup is going to be normal. Every subgroup. And use this theorem. This theorem saying that inverse image of a normal subgroup is normal under any group homomorphism. In fact, determinant is one such group homomorphism. Inverse image of normal subgroup is normal, but any subgroup of F star is normal because abelian. Since F star is abelian, which is abelian, any subgroup is not going to be normal. So inverse image of any subgroup in GLN of is normal. In particular, 1. I know 1 will be there. I don't know about 0 or any other element. Of course, 0 will not be here, but 1 will be there. So clearly that 1, the inverse image of 1 is called a special linear group. Yes, L n of F. That is A in GLN of F such that det of A is 1. But not only this, we can make a lot of things. We can make really a lot of things. So I have mentioned here, look at this. Determinant is plus or minus 1. Yeah, if it is plus or minus 1, yes. Set of all, because plus or minus 1 in F star is a subgroup. Sometimes the plus 1 is equal to minus 1 in the case of Z2. Sometimes it happens that, okay, but still, any field extension of Z2, this is happening, but that's okay, leave it. That's kind of an easy case to understand. But other than that, there is many field other than Z2, right? And its extensions. There are many field where plus 1 and minus 1 different. If it is real, if you put real, and if you choose F to be real, it's or C, this is called ON. Not ON exactly, but ON is a kind of sub. Orthogonal group kind of sub to this, okay? But it's not exactly orthogonal. It's much more than that. But can you see the power of this theorem? This one theorem saying that using the results which seems basically look at the F star, any subgroup. For example, nth root of unity. Take this. Now I'm in C, GLN of C to C star. Bitmap. And take any nth root of unity. So determinant inverse of nth root of unity, that is collection of A belongs to GLN of C such that bit of C. It's a single complex number. Bit of A, sorry. Single complex number. Power n equal to 1. Fix that n. That K. Let's say K. Because I used n here. Since I have used n here, I don't like to use n. Fix that K. Determinant of K. This is normal. And people ask this kind of questions in the exam. This is normal. This is an IIT second level exam after GATE, CSIR. In the MSc level, if you qualified, every IIT contains their own second level exam. They're asking such kind of a one word question. Is it true? In fact, this is also true. So I technically should put this technically, but doesn't matter because I have taken everything non-zero. So this is one such question. Q. See, remember that I'm taking all the A, which is GLN of C, such that det of A belongs to Q. Of course, it's not going to touch this. So C, I can put this also Q star. But Q star inside C, it's a normal subgroup. Of course, C star is a abelian subgroup. Q star is a normal subgroup. So this is the inverse image of Q star. This is nothing but det inverse of Q star, which is a inverse image of a normal subgroup, right? So it's normal. So one can go further. Now this thing, R star greater than 0, which is again C star. It's a subgroup. Multiplication of two positive real numbers giving a positive real number. Inverse of a positive real number is a positive real number. So inside C star is actually a normal subgroup. So inverse image, this is nothing but inverse image of det of R star greater than 0. Positive real number. So it's a normal. And so on, one can create. Now you can come up with your own idea. You can ask like, okay, what if it's taking only integer? Determinant is only integers. Can we say like, yes? The power, okay, it's usually in the linear algebra class, suppose a master teaches, very good teacher, they always mention this. Look at the power, even though GLN of S is not abelian. For n greater than or equal to 2, this is not abelian. This is not abelian. It cannot be abelian. But still, underlying F star is abelian. Using that, we can have a very good glimpse. So glimpse by glimpse, portion by portion, one can understand. Okay, fine. So this much is good. Now I introduce the homomorphism. Again, this is point of, like exam point of view, other thing it's okay. But as a practice, I just taken this practice. Now let's go into the really deep question, which is 2016 NBSM question. They asked two questions, which is easy. Any BSc level student who had a very good familiarity with the group theory can understand. This is an NBSM question, 2016 PhD entrance exam question. So make sure that you are able to understand this. Okay, 2016 January question paper, you can go and see that. Using Lagrange's theorem, suppose if I start with a group and a normal subgroup, let's say proper normal subgroup, using Lagrange's theorem, we can say that order of the group is order of this by order of this. And of course, this is greater than 1. I made it proper, okay? Once again. Proper, let us say the non-trivial. Non-trivial. So this is greater than 1. No, I don't care about proper. I want always non-trivial. Suppose you are non-trivial, the order is greater than 1. So that implies G. Cut down is less than order G. Because greater than 1, if I left, it will be at least half the size. So the proper finite, is it true in the infinite level? Basically, I'm asking, is it true? If the question, if generally, I start with a subgroup, normal subgroup, let's say normal subgroup of not trivial, okay, not trivial. G by N, it's again group. It is isomorphic to G itself. In the final group, it is not possible. After the cutting down, it's not possible. In fact, suppose G is isomorphic to G by N, infinite groups. Order of G equal to order of G divided by order of N. So that implies order of N equal to 1. That says it's trivial. But what about infinite group? That is not true. In the infinite group, it is not true. And this is where I wanted to give you a slight geometrical approach, and which is more helpful to have a sharp intuition so that you can prove logically. First, I'm going to give a rough intuition, and the intuition will get strong so that we can go deep into that. Okay. So let me give the rough intuition first. So two questions I'm going to write. One, C star quotient by S1. These are very nice. What is S1? Set of all Z such that mod Z equal to 1. You know what is C star, right? C star is nothing but C minus 0. What it is? Can we say something like this? So geometry will help us. This is like a practice. This is an NBSM question. My real idea is not to prove this, but anyway, this will help us to prove something. Geometrically, any non-zero number can be represented, any Z can be represented R into e power I theta, correct? Basically, I'm cutting down by e power I theta. Another representation, e power I theta, says that theta belongs to natural number. Sorry, real number. This is just look at closer that what I am cutting down of. I'm talking roughly. I'm not really making perfect statement, but I will make it perfect statement once after this intuition develop. Basically, I'm cutting down. A typical element looks like e power I theta, and I'm cutting down by e power I theta. So let me use the word observe. That's why I introduced observe. This e power I thetas are getting observed because it's made of that. S1 is made of that. So what is I'm remaining with? I'm remaining with R. That is greater than 0 always because it's non-zero. So basically, what I'm trying to say that R e power I theta, this is observed into S1. Only I leave with R greater than 0. So I have a good idea. Okay, the remainings are just greater than 0 numbers. So it's a positive real number. can I do something like that using first fundamental theorem? First fundamental theorem says that whenever you wanted to identify the codomain, give a onto map from G to here onto homomorphism, and that will help you to understand kernel of P G dash. That's what I'm going to do. Clearly, I have to start from here, and after this intuition getting developed, I know that my target going to be, R greater than 0. And clearly the map, the e power I theta is observed. That suggests me, okay, let me give you this map. Just like this, nothing else. This is a homomorphism, right? R1 e power theta 1 into R2 e power I theta 2 is technically, if you multiply here, this is R1 R2 e power I theta 1 plus theta 2, which maps to R1 and R2. Here it's mapped to R1, here it's mapped to R2, and if you multiply this together, you will get it. So from this direction, if you come, from this direction, if you go, you get the same answer. This is the group homomorphism. What is kernel? Kernel of this. And is it onto group homomorphism? Yes. Onto group homomorphism? Yes. Is it onto? Yes. Why? You take an element R greater than 0, and you choose that same element here. That's one complex number that it will cover. So it's R. It's in fact, when you restrict to R star greater than 0, this is identity. Okay. What is a kernel? Kernel is set of all R e power I theta such that P. So let me call this map like a phi. P R e power I theta is 1, which is nothing but R. By definition, it only catches the R. That's how I define here. That implies this is whole S1. No matter what is theta, no matter what is as long as R1. So I can get only condition on R. The theta condition is unrestricted. So any theta works. Any real number for the theta works. So it's exactly whole S1. This implies S1. So kernel of P is exactly S1. Okay, very good. So far, so good. But the next question is very important. This is the question. What is the question? The question is S1. Take Wn to be nth root of unity. One can give precise e power format, that is e power 2 pi I k by n, where k equal to 0, 1 up to n minus 1. Okay, and this is actually Wn, precise description, nth root of unity. So what happens when we quotient? Of course, I don't care about normalities as long as it's a group, it's okay, because many things we are dealing with is abelian. So no need to check the normality again. So what is this? And I have written the answer. The answer is again isomorphic to S1. And this is very surprising. For example, plus or minus 1 is S1. S1, 1 omega square quotient is again S1. Or S1 divided, quotient by plus or minus 1 plus or minus I. And this is again S1. And this is much more beautiful, right? However, the big n can be anything, it doesn't matter. But what is the basic geometrical idea hiding here? So let me explain you the geometrical idea. Okay, this is the geometrical idea which is hiding here, and this will help you. First, as we started with C star, I'm starting with the S1. What is S1? S1 is a circle. Let's develop this intuition, and that intuition will help us to define this properly. Okay, so start with S1. I'm looking for S1 quotient by this. For example, we'll take n equal to 4. What are the points? This is a point, one such point. I minus 1 minus I. 1 I minus 1, minus I. These are the four roots of unity. When n equal to 4, plus or minus 1, plus or minus I. And Sn quotient with plus or minus 1, plus or minus I wanted to understand them. Just use the phrase. Whenever there is a I or 1, it's getting observed, right? Whenever there is a 1 and there is a I, it's getting observed. And so far, polar coordinates are in great help with us, right? Polar coordinates are in a very, very great help, very nice help with us. So we have to use here also polar coordinates. So give me a moment. Let me drink water. Let me drink water. Yes. So the polar coordinates are in a great help. Remember that. The basic definition for S1 quotient plus or minus 1 plus or minus I, let me use omega 4, is actually cosets. First coset itself plus or minus 1 plus or minus I. That is these 4 points. These 4 points together. As a one single point in the quotient group, as a single point quotient group. And so the next number, the next point, this is like the omega n and g dot omega n. So this is e power I theta 4. So the rest of the thing, I have to take one element, hit all this 4 to get another element. That is, this plus or minus 1 plus or minus I will get hit by I power I theta. Take one element here, such a e power I theta. The theta bit greater than 0 between pi by 2 here. So that actually multiply e power I theta. So this element will come. Let me use another color. This element will come. This element will come. This element will come. This element. That is, if you catch this one element, you will get it. You start with this element, you will get this element, you will get this element, you will get this element. It seems for me, first we are introducing the geometrical thing. Sorry. So let me remove this, guys. It seems this is rotating as moving. Okay. Sorry. Oh. Yes. This is getting rotated, okay, to this point. So this is getting rotated towards this point. This is getting rotated. That is, it is enough to catch all these 4 points. If you catch this guy, it's enough. If you catch the second thing, if you catch this guy, is enough. If you want to catch this guy, this all 4, if you catch this guy, is enough. It seems that this whole arc is enough to catch all these guys. Again, I'm telling you, in the quotient group, a typical thing will be like this. A typical element will be like this. Something from the group into the subgroup. So if I start with this is a trivial thing in the quotient group. If I start with this guy, it will be here. So anything, it's enough to catch by one something. That seems that this one whole arc sort of enough to catch all the other element 4. And remember that, let us take that whole arc, which is 1, which is high. But this is getting identified. This 1 and I also getting identified. If it is getting identified, again, it will be like whole circle. So this is the idea behind that geometrical idea behind all things. Okay. But I have to make it very precise. Very precise means algebraically precise. There is no compromise in algebraically precise. Okay, this is I done. Sorry. This is I have done. C star by S1 is again isomorphic to R star greater than 0. Now I'm looking for this one. Sorry. Positive real numbers, what happens? Okay. This one. S1 quotient by omega generally. So I can able to understand. I like to prove this is S1. That means I have to start from what? I have to start from here. S1 to S1, I should go on to map, homomorphism, such that the kernel is this. What is the map? This is the map. This is the map. This is the homomorphism. Z1, Z2 power n is actually Z1 power n, Z2 power n. This is the homomorphism. Clearly, this is the homomorphism. Point number 1. Second, onto. To prove onto what I need to prove? I need to take a W, one element, let's say W belongs to S1, which will be looking like e power I theta, right? So set Z to be e power I theta by n. So set going to e power I theta by n power n, which is e power I theta for some theta, that's W. That's W, it's on to map, very easy, it's on to map. So S1 to S1, by the way, this in higher math we use for onto, this is for injective. And this is for bijective. We have onto. What is kernel? Let's call this name. Kernel of P is set of all Z such that phi of Z is 1. One is identity. It's a set of all Z such that Z power n equal to 1. And which is exactly nth root of unity, right? So that says that when you quotient by nth root of unity, first isomorphism theorem or fundamental theorem of homomorphism saying that S1. However big, how much big, doesn't matter. And this is actually one of the beautiful facts which is an algebraic topology plays a vital role. In algebraic topology, if you're able to understand this is in the algebra context, when algebraic topology comes, you don't have to worry. You don't have to worry. Okay? Yes. So far, so good. So one more thing, just wanted to make sure this geometrical ideas are like we are good at this geometrical idea. One more question. It has been asked in a different NBSM exam somewhere, but still easy. What happens to this? What happens to this actually? Can you explicitly identify what is this? This isomorphic. Can you give an explicit description? Again, let's understand from the geometrical perspective. What is happening? 0 is here, 1 is here, -1 is here, 2 is here, -2 is here. Okay? All these guys, remember that. They're identified as one single element in the quotient group in the level of quotient group. They're identified like a Z, one element, one single element. What is the next? So, and so on. But the general description is R plus Z such that R varies over real numbers. That is the next. Let me duplicate this. In the next level, so this is the first level, okay? If you hit by R, it will be getting translated. It will get translated. It will get translated. So let me change the style. Yes. its initial level is this with 0, hit by 0, then hit by some number, it will be like this. Hit by some number, it will be like this. Hit by some number, it will be like this. But if you slowly move, exactly in the around 1, it will be identified. That is, this R can be even restricted. What I'm trying to say here, oh, sorry. I'm trying to say that, okay. Within this, the framework of 1 and 0, everything end. Even if you choose the higher, it doesn't matter. Basically, we have seen this. What we have seen this, AH equal to BH, if and only if B inverse H. In the context of minus, R1 plus H equal to R2 plus H, if and only if R2 minus R1 belongs to H. That is an integer. So that says that if you wanted to catch just Z, this is okay as a one identification. If you want to catch other elements, just hit by that. This is okay. This is okay. So that implies everything happening within this. Everything happening within this. And these two are getting identified. As an integer, both 0 and 1 are same, right? This is 2 are getting identified. So I'm getting a circle. Again, I'm getting a circle. Again, this is an intuition. You may not understand. Why should you understand? First of all, from my point of view, I'm just giving. But once I make it precise, you have to agree with me. There is nothing called like different opinion, difference of opinion. You may not understand me because of this intuition, but I getting as a circle. So how to make it sure? So simple. Again, the same thing. I have to give to circle S1 onto homosome. This is what I have to do. This is what I have to do. Find the onto homosome. It's going to that. I can able to understand. So the onto homosome is nothing but R. Okay, let's say T. T going to e power 2 pi I T. And this is onto homosome. In fact, S1 is represented to this. This is an onto homosome. From your analysis, from many perspective, one can understand this is onto homosome. And this is actually, okay, this is actually the kernel of this phi is just Z. So R by Z is S1. I'm making a point here. The point is, I like to not give you the solutions, of course. The one who is focusing on the solution may miss the point. Rather, the one who focus on the technique will get the point. The technique is matter. All these examples are captured to make sure the techniques are understandable to you. Okay, techniques are understandable by you. That's it. Nothing more, nothing less. The technique, whether the techniques are understandable by you or not. That's the only question. This is okay. So one more question I can post in this direction using the technical team. Just one more question. So the one more question is very beautiful question. Give me a moment. Yes, this is a beautiful question. The same direction. It's in the Galleon book. Please refer the Galleon book for the question. I think question number 31 is one of the basic interview question for MA MSc student who came for a MA MSc scholarship to IMSc. They asked this question. R star denote, R star denote R minus 0. R plus denotes the positive real number. Just positive real number, okay? R star is isomorphic to Okay, so this is what we wanted to prove again. What we wanted to prove actually, R star is non-negative numbers are two part of using this. And this is not very surprising, which is able to understand easily, but this will lead to the next question. This is not the original question, but the next question. This is the 31st question in the book, but it will lead to the next question. In IMS, they ask tricky question, okay? But all this tricky question based on the known question. This is very easy. They said, okay, take the hint, R star proof. That we can understand, no? Geometrically, just zero is removed. Either is positive or negative. Oh, what is the thing? R star 2 plus or minus 1 cross R star greater than 0 is actually x going to sign of x. Whether it's a positive sign, negative sign, mod x. That's it. This homomorphism will do. It's not very big surprise. This is not very big surprise, and this is not the original question. Of course, they don't ask this very easy questions, okay? The question is, okay, this is the question. Find all the subgroup of R star with finite index. This question may seem a little tougher at the initial glimpse. If you read this question, it may seem something tougher, but I'm telling you, with all this idea, whatever we have, it is easy. It is easy. I'm telling you. All you need to know. Before that, let me pause a moment and let us understand something. Why we are trying to identify? You may ask the question even before. Okay, sir. What is the point of identifying? I know as a group this exists. What is the point of identifying this R greater than 0? Or what is the point of identifying this? Because such a questions can be tackled even when you have something very concrete on the left side, not like a quotient. Things are greater, things are easier to understand because which is already a simple, nicer group, which is some much more simplicity. So this is a question. It seems at the glimpse, it's a very hard. Can you class find all the subgroups, like all the subgroups of the finite index? Well, of course, R star is one such subgroup, which is also finite index of index 1. Yes. So R greater than 0 is one such subgroup of index 2. Are there more? So example, R star itself index 1. R greater than 0, index 2. Are there more? No. They are not. They are not. So answer is very simple. No, not more than this. You can ask me why. Why there is no. Suppose let us have a subgroup of R star with finite index. Finite index means R star by H is actually finite. This is a meaning of finite index, right? Not, that's very simple definition. This is a moment of finite index. If H is a proper, suppose H is a proper, then just now we identified R with a plus or minus 1 cross R greater than 0. Case 1, H is completely contained in R greater than 0. And also assume that it is a finite index, okay? It's a finite index. It cannot be trivial. It cannot be, if it is trivial, it cannot be finite index. It cannot be civil. So case 1, it contains this. It is contained here. And you can see that is, since it's a finite index, R star by R greater than 0 is of index 2. Just because of the identification. See the identification. These are two elements. When you quotient by r greater than 0, this will go. So you will get only 2. So it's of index 2. And in my case, I assumed, in my case, I assumed this is here. Okay. So r star r greater than 0, it is 2, which is r star h. So yeah, sorry, h. This is finite. R greater than 0 into multiplied r greater than 0 h. Our property, no? Suppose this contain in K, contain H, G by H, index of G by H equal to G by K, KH. In that way. So we know this is 2, H. This is finite. Implies R greater than 0, H is finite. But this is a basic question everybody has know. Can we have a finite index subgroup in R greater than 0? Even if a non-trivial subgroup, let's say non-trivial subgroup. Suppose there is a non-trivial subgroup, which is inside R greater than 0. There is a non-zero number, and it is not a finite index. Then you can generate the whole thing. It will come out. Okay. So I recommend you to prove that this R greater than 0 is actual H. And case 2 is another case. In the case 2, H does not contain in R greater than 0. That means it has a one more element. Okay, it has a one more element, which is minus. Which has a one more element, which is minus. What happens to that? In the case, you can prove that H is the whole thing. Okay, I will forward the solution today evening or tomorrow. I will leave it to you. But I have a solution, just four-line written solution for this. But I want you to think about this, right? So at this point, let me conclude the lecture of saying I wanted to talk about little bit about a normal subgroup, but normal subgroup and Solo's theorems are little beyond the jumps perspective. It is used for MSc perspective. Probably if I get another chance to give a talk, I will talk about this. But you can always refer to that YouTube channel where everything is like done clearly. What is group action? The theoretical aspect of group action and the application aspect of group action done very clearly. You may ask the question in WhatsApp in the group section or somewhere like I will share my WhatsApp in the group. You can ask the questions, okay? Okay, let me stop it here and let's have an interaction. If you have a question or something, we can talk. Okay, sir. Sir, I finished. So you encourage people to ask questions if they have.
Thank you, Jay, for this
Yes,
wonderful and interesting session on normal subgroups. And now it is time for interaction.
Thank you, sir, for this wonderful session. Sir, I have some questions like
yes.
when we are doing the problem by geometric aspect or and then algebraic aspect like in when we have proved that uh, S1 S1 omega
Portion by
n,
the
yes,
omega.
sir,
Yes.
is isomorphic to S1. Then I am taking what I am want to know the homomorphism like say, Z. We are taking Z to the power n equal to Z to the power n. Phi Z is Z to the power n.
Yeah, so z going to z to the power n. That is a homomorphism. That is suggested by the idea of, see, first, once, let me share the screen maybe. Can I share the screen?
Yeah, of course.
So, basically, what happens is, this is the map. So the idea of the map is mysterious. Suppose somebody teaching you without motivation, they will say, okay, take S1 to S1, Z going to Z10. This is the map. We don't have a motivation at all. But this motivation comes through this. What happens to here? After dividing this, remember, assume that I have no idea. I just wanted to understand, even I don't know. I just being asked this question and I like to know what it is. So, but I know that, take the one example, like 1 omega square. I wanted to work on this. So 1 is here, omega is here, omega square is here. Correct?
Yes, sir.
So geometrically, this is the meaning. So diagonal things are coming on. Geometrically, this is the meaning. So the next one, a typical element will be e power I theta, such that theta belongs to real number. I will hit by S1 element, right? I will hit by element of S1. Okay.
Yes.
Yes. I will hit by element of S1. So what happens? This is e power I theta. It is also some e power I phi 1. Let's say e power I phi 2. It will be enlarged by theta. It will enlarge by theta. So basically, this triangle little bit rotated. So that means this arc, if I start with this point, this triangle is like this triangle will go like this. So this triangle is actually taking. Once if we move this triangle, this will move like this will move like this. So that says that this arc is a matter. This arc is a representation working. So this arc, 1 and omega. But this 1 and omega also identify together now because of this line. So basically this line. And if you make it sure, this line is again coming like a circle. This first suggests me that, so giving me the idea, this is isomorphic to S1. This is the first idea, but still I am not technically proved. Then I'm thinking what to do. And I'm looking at the nature of this. First I got this idea. I know where I have to land. Once I have to land, looking at this, what is this? Set of all z, such that z power n equal to 1. And this giving me idea, okay, why don't I define phi z to be z power n? Because this map is giving me idea. Since I know I am landing here, this map is giving the idea. So in generally, go for that, okay? Then I define z goes to z. That is the perfect motivation. Once you know where you wanted to land, doing the map is very easy, simply easy. Okay.
Okay, sir.
Am I answered your question?
Yes, sir. Yes, sir.
Yes, sir. Okay, thank you.
Sir, one more thing, sir. In which,
Yes.
I mean, you told about Galilean, but I mean, like this type of rotations, it's not which book we should follow for group theory for geometric aspects.
Oh, geometric aspects. Okay. The book I will suggest is Michael Artin, but in the level of BSc, it's slightly difficult without a teacher. So in PhD, what we say, Michael Artin is very enjoyable, very, very enjoyable. David and Foot is like a dictionary. I personally feel like it is like a dictionary. Whenever you want, you can go and refer, like exactly like English dictionary. Michael Artin, I personally prefer. So there are a lot of extra questions. Even if you don't know the answer, go to the internet. There will be a small discussion section or somewhere in the internet, especially Math Stack Exchange. They will tell you about geometrical aspects. Okay. So the best book is Michael Artin. But I wanted to warn you, without a teacher, Michael Artin takes some time to understand. you may understand the statement, you may understand, able to reproduce the things, but the glimpse, the inner glimpse, what is really going on, it is easier, faster. Anyone can understand. There is no problem. Anyone after the effect can understand. But if there is a teacher, it is faster, right? So Damit and Foot is the standard thing. But I will always suggest geometrical aspect, Michael Artin, algebra by Michael Artin. Okay.
Okay, sir. Thank you, sir.
Yes.
Thank you, Dia. Jay, you may turn off that presentation. Yeah.
Oh, yes, yes.
Jay, Dia is actually an MSc student from IIT Bhubaneswar.
I see. Okay. Oh.
Yes, sir. Yes.
Okay.
She
I have been in
qualified
a nicer Bhubaneswar actually.
Yes, sir. It's just adjacent to our institute.
I see.
She already cleared JRF, and after MSc, she would like to join in a premier
Do
institute.
PhD in a very good institute like IMSc and TFR, right?
Yes, sir. I am trying.
If you follow this kind of lectures, no, you will definitely. So no, you will definitely able to achieve it. So the way I construct a lecture, it will be useful for a level of student. So I prefer the way information, confirmation, and transformation. The people from BSc, you know, they are in the BSc, wanted to go for MSc. They are like the informed people. So whatever I'm giving, it's kind of a new to them. Most of the things are new, so they have to take some time and assimilate. For the MSc level of student, they already cleared, the level of BSc. They need to get the confirmation. But the PhD level of student also, it is useful. They can understand how to sort the notation, how to kind of organize so that it will be centralized and related. So it's a transformation situation. So I hope that you will also join in a good institute, then you will see more kind of this sort of things in the, like IMSc. But I know IMSc because I am from IMSc. There are many people inspired me. They are in the level of confirmation. So if you keep your level up in the confirmation level, then you can able to transformation level. So good teacher will transform you just like that. Okay, so all the best.
Thank you, sir.
Okay, thank you, Dia.
Any other questions?
Others, please.
Good afternoon,
Yeah.
sir.
Yeah, Shikha.
I'm Shikha, MSc second year student from Birla Institute of Technology, Meshra, Jharkhand. So the session was really nice. Your explanation was very easy to understand, and overall, it was very much beneficial for us. Thank you, sir, for this session.
Thank you.
Thank you, Vinod, sir, for conducting such kind of session.
Yes, we have to thank him actually. He asked me much before, but due to some reason I'm not able to do. But I really enjoyed to thank. For me, I don't know about you people. For me, this 1.5 hour goes just like that. It's beautiful, pleasureful time. Okay, one of my teachers says that if you're not able to feel the time, you are at the present. That's what happened to me. I am into it. So even it is offline. Okay, if online like. In the offline, it is very nice, very easy to mingle with the people. In the presence, making it at the offline is much more difficult, which I know. Giving 3 hours lecture in the offline, it's much more easier than online. But in online also, I felt very nice. Many students are involved, that I can see. Okay, thank you for that. Yes. Do you have a specific question or something?
No, sir.
Yes. Then thank you for the feedback.
Thank you, Shikha. Others?
Hello, sir.
Yes.
Hello, sir.
Yeah. Yes, Gayatri, you can.
Yes.
Hello, sir. I'm Gayatri. I have studied in Miranda House College, Delhi. The class was very nice, but it was a bit tough for me to understand some of the points. But your explanation was so good. And thank you for taking a wonderful class for us. And I would like to ask you about your preparation for NVHM exam.
Okay. May I tell you a little later? They may have some questions. I will tell you about NVHM, yes, but little later. Huh? Is it okay?
Okay, sir.
Yeah, just you want to see the road I travel for NVHM, right? Okay, I will share that. Okay. What about the other student?
Okay. Okay, Sharada, you started to say something. Please continue.
Hello, sir. My name is Sharda. I'm a BSc student. Thank you very much for this wonderful section. Actually, many things were new to me, but
Right,
I
of
felt
course.
that the section was unique and special. So thank you very much. Vinod,
Thank you.
sir, thank you very much for organizing such a session. Thank you.
Thank you, Sarada. Others?
Sir,
Yes.
Sir, I'm Dinaki from
Yes.
Government Victoria College, Palakkad. Sir, first of all, thank you for an excellent session. Sir, you had discussed several questions which are really helpful for me. And sir, in our college, we had just started group theory. We had just reached permutation group and cyclic group. So all you have taken was really new for me. Thank you for giving such a wonderful introduction, sir.
Thank you. It
Thank
will be
you.
easier for you once you encounter, because it's been given, okay? For the student who feel like this is new, remember that when I was in like attending IMSc lectures as a MSc student, I was in the MSc joining. I started attending classes like these classes in MSc. A group of people, they started teaching us. They started with a field theory. I have no idea. I asked the teacher the same question. I don't understand anything. He said that patiently observe. When you encounter, you will understand. Okay. So in the psychologically, there are three states. First state is a feelable state. Second state is a first encounter state. The third, the final state is deep subconscious state, like your name. Suppose if you encounter someone name, no, new, it is new to you. That is a feelable state. Then the name, if you continuously keep on encountering again, it will go into your mind. Then finally, if it is like even more using, that it will go to the very, very deep into it. Okay. This is what happened to me. I particularly want to say that I did not prepare much because this is what we are doing. So it's easy for me because I'm doing repeatedly as far as this concern. Okay. So anyone who feel like this is new and a little bit of higher to understand, remember that you are going to face it again. So it will be easy for there. Either you are going to have a little hard work here, then it will be easy there. Or if you are doing there, it will be easy for you. So it's a vice versa thing. Okay. Yes. Thank you. Thank you for your feedback.
Thank you.
Yes. Any other?
Dina?
Hello, sir. My name is Alina Anna Matthews. I'm a student of Marthoma College, Kerala. I'd like to thank you for spending your valuable time with us and putting up so much effort for taking this class. Thank you, sir. Thank you, Vinod, sir, for organizing such a class. Thank you, sir.
Thank you, Alina.
Yes. Thank you.
Hello, sir.
Yes.
Sir, thank you so much for today's session. It was very helpful. And sir, I wanted to know that if as our GATE exam is coming in February, so can you share how we can increase our rank or do better performance in GATE?
Right.
So I wanted to know that.
Right. Okay, I will share it.
Didi, you may introduce yourself too.
Yes, sir. Sir, I am a MSc second year student from NIT Trichy, and I am from West Bengal.
What's your full name then?
Sir, Tithi Biswas.
Okay. I will also answer this question along with the Gayatri question. Okay. So I will tell you some existential answers. So let me postpone this question. Okay. Another question.
Any others? Okay, dear students, please do come forward and take this chance to interact. No need to be afraid.
Yes.
No need to be shy. Yes.
Hi, sir. My name is Harita. I'm from Marthoma College from Kerala. Your class was same as others. I'm a BSc student. It was a bit tough, but still it was very interesting way of interaction, thought-provoking type of class. You're trying to make us think about these things. Try thinking, and it was very interesting to be in your class. And thank you so much. I will try even harder to understand what was these things. Thank you so much, sir, for valuable time.
Right.
Thank you, Harita. Any others? Yes.
I'm Verma from Zamurians Guriyarpan College, Kerala. And thank you for this good section. and it's so grateful for us for getting a class from you. And thank you, Vinod sir, for organizing such a good class for us.
Thank you, Vandana. Any others?
Hello, sir.
Yes, Gopika.
Hello, sir. I am Gopika from Guruyappan College, Kerala. It's a really nice session for us. It's really helpful for us for our JAM preparation. For me, it's a little bit difficult for me also. I'm a third year BSc student, but I think if I revise the class once more, I will get a little more clear. And thank you so much, sir, for spending a valuable time for us. And Vinod, sir, thank you so much for conducting this session for us.
Thank you, Gopika. Any others? Okay, yeah.
Good morning, sir.
Yeah.
Okay, yes.
I'm studying in
Good morning.
Riyasam Ramanujam Institute in Madras University. I feel like a little low in group theory, but this class, like, it encourages me to study more in it. It is good. Thank you, sir.
Thank you.
Thank you, Akshaya. Any others?
Good afternoon, sir.
Yes.
I'm doing my MSc Math at Etraj College.
Right. Chennai.
From Tamil Nadu.
Yes.
Yeah. So it's a very beautiful. It's the first. This class was very informative, and I felt very happy about that. And how to self-learn the group theory, sir, because I'm not so much strong in this group theory. Can you give me any suggestions about that?
Okay, definitely. I will give you the suggestion. Okay. So I will answer these 3 questions. There are 3 questions about the NVHM preparation, general preparation, and 1 question how to go for the gate, and this 1 question how particularly one can tackle the subject, right? Okay, so I will answer these 3 questions along. Is there any other feedback?
So, dear students, if any of you would like to make any comments or share any feedbacks, please do it now.
Yes, sir.
Yes,
I'm
Sarah.
Ramita from TMT College, Malappuram. I'm first year BSc Max student. This class is very wonderful. And can you give any tips that how can I prepare for competitive exams from now?
Right.
I mean, from first year BSc.
Okay. Right. I will give you. I will share. I will give you. I wanted to share, not giving anything. I will share. This question also related to the question they asked 3. I will give you in the 3-4 levels. Okay, level 1, level 2, level 3. You will understand what I'm trying to say. Okay, I will give you.
Thanks, sir.
Any more questions?
Yeah. Thank you, Sahra. Someone has also started to speak. Please do.
Hello, sir. I'm Ankita Gupta from Central University of Allahabad. I have done MSc class 2019. Thank you, sir, for wonderful this session.
Okay.
Thank you.
From where you did MSc?
Yes, sir.
From where did you completed your MSc?
Central University of Allahabad.
Allahabad, okay.
Thank
M1 NIT, right? Not different from that.
No, sir. University of Allahabad.
Allahabad.
Central University of Allahabad.
Allahabad.
NIT is different.
Oh, the name now. Okay, I got confused. It's a Prayagraj now, right? Officially, okay. I just got confused. Okay, sorry.
That is an NIT, and the Ankita's institution is the Central University.
Yes, sir. I understood. Yes. I have some few people. They always say Central University of Prayagraj suddenly. That's what I got confused.
No, sir.
Sorry, it's okay. Okay. Yeah, thank you.
Thank you, sir.
Thank you, Ankita. Jay, I think now it is time to share your tips for the students who are preparing for competitive exams.
Yes, so I can give you from this point of view. See, there was something, the level of physical and the second level and the mind level of mind. There are 3 things need to be understood. So the question asked by Gayatri what is your way? I will share the way what I went. But before even that, I will give you some existential exam type of tip. That's question related to the gate and everything. So I will give you 2-3 points which I observed from the way I train to my thing, which are existential, which are not kind of psychological or motivational, which are existential. Okay. First of all, giving 2-3 hours of exam, especially now in this era, I used to do it in a writing, correct? I used to do everything in a writing thing. We don't have a eye strainer much more, but now it is much more eye strainable. So I cannot able to work, especially me, able to work more than 2-3 hours of in the computer. Even typing is also hard. So along with my friends, we found out a few examples that one can understand easy. I have seen students who take 2 water bottles there in the exam hall. One is actually for just water. Another one is actually glucose. So this is one of the existential tip which can be useful. They always share to me, okay, there are a certain group of people who go for the CA exam, and that particular group of students shared me, after 1 or 2 hours, because of our thinking, we are exhausted. Our mind, even our hand refuse to write and work it. So if you have a 2 bottle, one of glucose or like chocolate or something, it will be more useful. So this is one such example, one such tip that if you carry 2 kind of water bottle, I don't know about solid food, but 2 kind of water bottle, after 1.5 hours, you may feel little exhausted, but that glucose bottle will help. This I have seen in CA, in ICCA Institute, a certain group of people from certain institute, they are following this trick, okay? This can be done by in our section also. After 1.5 hours of this exams online and seeing continuously, our eyes are getting little tired and refuse to even, overcome. So we forward, little carry forward. So this kind of 10 set of tips are there. Maybe I will share these 10 tips to you people in the group, maybe in a voice, or I will make it. This is one such thing. Second, you might have experienced the same. Suppose you are going somewhere in the, like, let's say, cinema theater, okay? Outside is so bright. Whenever you enter in the cinema theater, you may feel like it is little darker, but it will be equal after a certain time. Our body gets adapted, right? After coming out of the cinema theater, you feel that the outer is much brighter. This happens in the sunny days. So you can always see that our body takes some time to adopt these things. So that's why those students also start with the same tip. If you're able to go like 10 to 15 minutes earlier and sit down, our body, it takes some time to adopt all these things. So they always go early. The people, even they go early for the exam, they may not go and sit, take some time to settle down, and those times are completely waste. So these are the second tips. Like this, I have a 10 tips that I will share you later, and this can be gradual increase. In fact, this CA Institute, they told the student that this increases 20 to 30% of their potentiality. That means a student able to answer 100 questions, they can able to answer 130 questions. All these IIM institutes and other people are secretly following these techniques. Okay, so I will share all these techniques, tricks, which are much more existential and which is doable in the level of body. Okay, which is doable in the level of body. I'll share at least 5-6 tips are very easy to follow. Okay. Second one, the question is for BSc person, and somebody asked me like this, right? So let's say I wanted to start from group theory. What I wanted to do, as I said, we can split into 3 levels: information level, confirmation level, transformation level. Okay, so let us understand information level kind of BSc. In the BSc, we are getting informed. The best book to start is Gallium. Also, there are very nice set of notes written for algebra by professor called Keith Cornett. It's a very beautiful, there are very beautiful notes, very clear, very nice notes are there. Absolutely free. If you put his name, Keith Cornett, KEITHCONARD, Cornett, you can get it, expository class, okay? All the expository notes are there. Some of my professor even prized him. Some of the CMA students wrote him that they thanked him just because of the notes. It's much more clear. So in the level of a BSc, even in the MSc level, one can go and check Keith Connor notes. Okay. Once if you're checking these people, you can also understand the basic desire. It will be created in you. We have a professor called K.N. Raghavan. He actually created much more desires to learn theory of groups. Okay. So what he used to say, in the finite group, all the simple groups are completely classified. Completely classified means all mathematicians together came with for the one cause to classify that. They classified. And they said these are the exactly finite subgroups, and it has 4 types. And there is a one, I think the name Professor Cook written a blog about that. I used to see. For this class also, I saw the blog. I will share the link. You go and see. He lists down all these 5 groups, and he will tell what is a group. For example, the first thing is finite cyclic prime order groups. That can be understandable in the level of BSc. Any BSc people can prove that is a simple. If you come to the MSc level, AN is simple for n greater than or equal to 5. That is another second level. If you go a little deep in the first year of MSc, first year of PhD in the coursework, they will prove that TSLN type called a Lie type group. Okay, it is a MSc level. PhD level. They will prove it. And after that, there are only 26 prosodic groups which are simple and which is not fitting into any of this category. And this will create a basic desire to understand them. Okay, there are 26 more groups which are not. So there are type of Thompson groups are there. So this kind of answers will be, words will be thrown in the lectures. Professor K.N. Raghavan also keep mentioning that this is why you have to attend the talk. Certainly at some point of time you may get, interest. Okay, what is this? I got the interest in group theory because of that. I went to him and I discussed about him, what is this thing? And he explained that, yeah, so proving that is simple is not the hard. It is easy to prove them of simple. After little bit of effect, PhD student can able to prove. But why these are the only simple? That is interesting. And he mentioned that only countable number of people, not even 10 people know this thing in the world. If you know this, you will be like 11 or 12, or at least within top 20. So that is one of my aim before, I am like going out of this thing, like in the sense of like, even using this YouTube and other thing. My idea is to give you why these are simple and why that is only simple. That is a lifetime goal to understand of me. I got basic desire. So this desire can be created by attending this talk. That is one of the richest source to getting such a good and the right desires. Okay, right desires, right? You may like algebra. You may not, maybe you are more comfortable with the topology. So in the topology, there are certain things when you attend these talks, they throw. One of my professor named Pralay Chatterjee from IMSc, he used to throw these words. He always says that he will create the desire. That's what I'm trying also here. I'm trying to create a certain environment so that you will just like that, okay? The flame will come to you. Whoever likes algebra, like innerly, they may not agree or don't know that they like algebra, but the inner, they may fascinated about the structure and the non-action things. Okay, there is structure understanding will get the flame if they just listen, and that flame will go, a long way. So I will say that if you wanted to really understand some subject, attend the talks like this. So I want to thank to any organizer, including Vinod sir, anyone who is doing these things. They're doing something great. To the future, the next generation people, they're making a platform to come here such that you can do something. So for example, in this talk itself, you got to know about Professor Keith Connor, you got to know about John D. Cook. They have a very written blog. You can go and check it. Suddenly something can spark, right? So this kind of things are given in the tongue. Whoever going after the talk working, this is also mentioned by Vijay Kodialam, one of my professor, and he's my advisor. Whoever after attending class go and checking, they can able to recall, and they may find something interesting, something fascinating. That is how Vijay sir used to find math, this area, and these places are like very deep into that. and he started working. He is basically trained as a commutative algebraist. Now he completely works on a non-commutative setup. Okay, from commutative to non-commutative setup, the transformation is not easy, but he somehow did it because of the passion. So at some point of time, people are getting inspiration from them. So attending the talks are great. Okay, another one thing. When you attend the classes, you may able to find it whether you like algebra or this side or that side. Then start following it. What is going on and see people what is doing on that very in the level of your level. Okay, and this will create a basic thing. Okay, now to answer the question from Gayatri, that once if you have a desire, like certain desire created, a right desire created, so you wanted to have a career on this, right? You cannot go like for out of this. I need to eat, I need to stay, I need to feed people, help my parents. So government and other people have a very nice programs like NBHM program, CSR program, which can be helpful, right? Then the first thing what I did, my journey, I found out that I like algebra more than other thing. Analysis for me it is a little difficult compared to algebra, but it comes very, but it's not natural as algebra. Then what I did, I started understanding which institute offers good algebra thing. IMSC have 6-7 algebra personnel. They may not be good in analysis compared to IISc. Algebra people are many people are in algebra, so I like to go IMSc. The same time when I got selected for IMSc, 4 other people got selected. Out of the 4, I know 2. They love algebra. Analysis more than algebra. They had a clear vision that they wanted to go for the analysis-oriented place. So they joined IISc. They got selected in both places. But they joined IISc just because of this fact, okay? Because they had a clear vision. So the first point, you start searching that. Once you have an idea, you know, suppose I wanted to join IMSc and I like algebra. Then more or less it's clear, right? The point is we have to clear the interview, the exam first, then the interview. Then automatically you start to work on this. You will search for this, okay, where to do. Once I fix it, I started searching. Like, sir, I also got one professor who suggested me, okay, if I don't know, I never cleared, but go to this person. So they introduced some persons like the teachers. So one of my professor introduced my senior Arun. He is right now faculty in IIT Madras. He is my senior. So I went to him and I asked the same question. And he said that, okay, continue to attend this kind of lectures. Whether you able to understand or not, continue to understand. Because it will go as a circle. I may also come again, will give you the same aspect in a different way, same thing. Then what happens that you will get into it and you will get more desire to do it, and you will ask the same basic question, how to clear the exam. So if you ask how to clear the exam, then you will have a problem, right? I know many people who clear the exam and having difficulty to join in IITs because they don't know about the second level exam. Let's say you cleared in the March, you got a confirmation that you cleared NBHM, interview also cleared. But remember that in the IIT, they always have a second level exam. You may not know. Every IITs have a different setup. The IIT Kanpur has a different kind of exam. IIT Madras has a different kind of exam. It changes every year. But I have a very good decision that I wanted to join IMSc. So that path is, the vision is very clear. I wanted to go. Then I started picking the people who can able to share that, not helping me, share that. Then I understood more or less this is what happening. One of my students said that he used to get very good mark, like in CSR, he got 120 mark and he could rank. But whenever he goes to the interviews, he had some problem. Then I gave him a tip, okay? You know that you are going to the interview, right? In this institute, like let's say IMSc, for example. I know there are some 7-8 professors are there who used to come to the interview. Go and see their videos, see the thing. Once you encounter, it is not completely new for you. Once it is not completely new for you, you may encounter very easily to them, right? So this is how I started preparation. Once I started preparation, certain kind of feeling came that I am a student of IMSc, I'm going to be the student of IMSc. It's more or less clear. So once the desire created, slowly, if you start working out towards that, you yourself will get the feel, and that feel will keep you up. That field will keep you up. That's it. So you have to keep contemplate over that. There's a beautiful word in English, not thinking. I'm not saying thinking, but there is a beautiful word. Go and check this word, contemplation. Contemplation means directed thinking. The more directed thinking you put to the desire, that will help you, and that will take you to the same thing. Music director A. Rahman, Dr. APJ Abdul Kalam all said the same thing, the universal response. This is called the universal response. So first you have to create the desire. Once the desire created, it's like a seed, like water, you have to put the contemplation over the desire, then it will help you. Along with this, like you are putting this fertilizers, right? Along with that, this attending the classes, certain things will help us, right? So already I have a very good touch in many institutes because of this. I started training students. There are at least some 8-10 good institutes. I have a very good connections. Also remember that once you attend, like for example, you are attending this thing and you are getting selected for IMSC, you can always come and ask me that, okay, so I wanted to give an interview this in IMSC. What are the things? Can you help me? Then people will deeply help. So the more you know the people, it's better in the relationship of in the educational level. That's why this kind of things. So now at least you have some comfortability with me. People don't know about IMSC, have at least some comfortability that okay, I can ask Jaykumar Anna. So he is there. It may help you. I may not be here. I will complete, but I can able to help you through my junior. So this is a legacy. That's why this kind of platforms are very much important, and you should use it. And it will be. You should be also grateful towards to this. How can you repay? Just complete this and complete your thoughts, clear this, and you can come and contribute from your side. And that's what I'm doing. That's the contribution. That is called the sharing. Okay, you are not giving back because nothing is going out of you. Rather than it's multiplying you. So it's a sharing, right? So this kind of platforms are so important. So to create desire, try to attend as many talks as possible from you. Even you don't understand, right? That's not the the speaker mistake, because it's our inner structure. You may not getting attracted towards it, but once the desire created, you start working on that, you will get it. And remember that at least they are giving certain money and some kind of advantages, this contingency, all those things. So technically, in the economical level, you will be okay. So you like to do something where you are getting paid. You have to contemplate over that also. Then you will see that the quality, how much I can work. I know one of my friend, he said that I'm not good for IMSC because I wanted to do applied thing. He just switched it towards IIT, and he is doing good. One of my joined friend also, she also wanted to do applied. She switched and she is doing good. So now she is in PDF in America. Okay, it will be clear once you started going multiple things. Okay, so some people, orchestra is good. Like me, I love always the musical orchestra. Some people, single flute player, single violin people, they like it. But I always like the orchestra because you may not know at what point of time, what point of musical instrument you are getting attracted to. That's why I always love. I take the same idea in everywhere. If you give me a chance to go to the something like, okay, let's say you go to this particular type of food or a buffet, I will prefer buffet because I don't know which will be helpful for you. That's why this kind of platforms are very much appreciable. It's not easy to conduct such a thing regularly also. So as a gratitudinal perspective, you should clear first and come and share. That's it, right? So I have seen around 3,000 people are in the Telegram group. And another one, okay, so as a gratitudinal purpose, this is also one can do. Even if you may not, if like for example, BSc student in the first year, second year, immediately they cannot clear and come back and contribute. No, at least keep support by attending, by subscribing their YouTube channel, by propagating towards others that this kind of things are there, so that more and more collective thought will come. Once more and more collective thought comes, automatically that collective thought will make it to grow this. And the conductor and the teacher who teaches will be also feeling happy. So you work towards this. And these are the 3 secret things that Joseph Murphy even mentioned in his book, The Power of Subconscious Mind, about students. If you wanted to read the entire book, it will take a long time, right? In The Power of Subconscious Mind. But if you go little beyond that, I mean, in particularly, I am kind of not follower of Buddha, but kind of a lover of Buddha. I love the way of Buddha. So he always says, when you are in the mid, you are not right or you are not wrong. You are always neither or always both. Okay, so you are trying to be centralized, but he also mentioned that the centralized thing will come to you once you started witnessing. That is what he called in his term vipassana. You started witnessing, but you see that witnessing on our own, it's little hard. But witnessing with the help, already the teacher knows, right? So witnessing with the help of the light of the teacher will lead you to the thing. That's why even in this case, doing certain thing offline or online, it's very good. So you started propagating. Once you started doing this, you will get the desire. Since you are doing it, you have to be kind of the guide, so that you will work on your own, because you are bringing other people. So this is another way of disciplining yourself. This is what Buddha said to us, right? Siddhartha Gautama said to us. Okay, fine. So I think I answered all of your questions about this. It's a psychological thing. Beyond the psychology, one should go. Okay, fine. Okay. What else? Is there anything else?
Thank you, Jay, for your wonderful session on group theory as well as these inspiring words. So let us hope that our students will be really understood what actually you mean by your words. So Jay, you please do share your slides as well as other informations which are that some books names, all that things can be shared, which can be circulated along with the recordings of our video. So I would like to, once again, I would like to thank Jay on behalf of our math aspirants groups for joining with us.
Thank you.
Okay, thank you everyone. Let us wind up here. Thank you.